This video is about the generate attributes operator. This operator creates new attributes within example sets. There's a lot of detail associated with this operator. This video focuses on the date and time functions. We'll look at converting string type attributes to date and time, and the reverse operation, date and time back to string. We'll look at Unix times, how to get the system time, calculating differences between dates, adding to dates, and then also finally rounding dates to a minute or hour multiple, which you might use when joining to other dates in other example sets. We'll start with the process. So it's a simple process. It generates a simple piece of data with a date in it as a string that gets passed to the generate attributes operator, where various attributes are created. Here you see there are 10, and there are various date and time functions used to create the new attributes based on the existing one or based on reuse of the ones that were just created. In general, if you click this button here, you can see the full range of functions available. We're using the ones in the date category at the moment, and we've picked some out of here. Obviously there are too many to cover every single one, but hopefully the ones in this video will give you a flavour of the sort of things you can do. So let's run the process. You'll see this is the original data. All it is a single attribute in a single example in the example set, and the attribute is of type nominal and contains a string, 3rd of February 94, 5:45 in the evening roughly. The result of the generate attributes operation is added new attributes to this single example. Here they all are. I've created a custom view which we'll use now to look at each one of these one by one in conjunction with the descriptions of the attributes and how they are created. I'll just change the layout so we get to see the whole thing. There we go. So let's start with the first one, date time my date. I've adopted a naming convention. Date time is the type of the attribute, my date is its name, and then at the end, where relevant, I'm going to put the units. So date time my date is of type date time, and it's my date that's been changed from a string to a date time type. You can see here date time my date. This is the result of this. It's of type date time, and it's based on the string my date attribute, which was provided as input to the generate attributes operation. And the way that it works is you use a function called dateParsCustom that takes at least a minimum of 2 arguments. The first is string my date, which in this case is the attribute containing 3rd of February 94. The second is a formatting string that dictates how to interpret each part of the string to convert it into a date and time. So these DDMMYY, if you're familiar with Java, you'll be familiar with these: date, month, year, hour, 24-hour format, minute and second. Obviously you can have different values here, different formatters, so there's a lot of flexibility about turning a string into a date. The date itself is here. You can see it's got it correct, and it said PM, so it's correctly interpreted the 17 as an afternoon. The next one is string myDateCustom. This is turning the date time attribute back into a string. I'm using a custom format again, so in this situation you use a function dateStruCustom, which converts a date back into a string, and the formatter here is now this YYMMDDHHM. You can read it yourself, and you can see that the result of that is a nominal, so it's a string, and it has the value 199402. You can see 3rd of February 94, 1744 as the original string. So by this method I've actually converted a string in one format to a string in another format, both representing a date. Unix time, so date time epoch, as you may know, the number of seconds since the 1st of January midnight 1970 is defined as 0. So I'm expecting this function called dateParse, which takes milliseconds, it's quite important, as an input, as an argument. That should return a date, and sure enough it has returned a date. For some reason it's put it 1 hour forward to what I'm expecting. There's some time zone issue which I can't work around. Nothing much I can do about it, that's the way it is, we have to accept it. So basically the Unix time 0 for me is 1 hour past what I'm expecting. Nonetheless, you can use the Unix times for various things which we'll see later. If you want to see the Unix seconds since the epoch, i.e. since the 1st of January 1970 for a date, well, this is me doing the calculation. I'm doing a date difference between the date and time of the epoch, which is the actual 1st of January as a date time argument, and my date expressed as a date time, which we calculated right at the very beginning in this attribute here. And I'm essentially saying do the difference between these two and pass that to datediff. That's the datediff function takes that difference. That returns a value in milliseconds, so by dividing by 1000 I get seconds, and by rounding I get it to the nearest second. So numeric my date Unix seconds, which is this, should be the number of seconds that my date in 1994 should be from the epoch. So it's something like 760 million seconds. The next one is, how do you find the system time? Well, there's a built-in function called date_now. It returns a date and time typed result, so that gets turned into this attribute here called dateTimeNow. So I'm running this at 6:10 in the morning on the 1st of January 2014. Happy New Year, everyone. And so by this method, every time I run this, I'll get a different value depending on what time it is. This next argument shows how I can calculate the difference in Unix time, milliseconds, since a date in the past and a date and another date in the future, whichever way around you want to do that. Again, I'm using the datediff function. If you remember, that returns milliseconds. So I'm calculating the date between the date in 1994 and now. There's about a 20-year gap. So on the back of my envelope, 32 million seconds in a year, 20 years, roughly 1,000 milliseconds. That's 640 billion seconds. Well, that's not too far from what this is, 630 billion. So I'm going to say, yep, that worked. So the number of milliseconds between the date 3rd of February 94 and now is about 628 billion milliseconds. Big deal? Well, you'll find this might be useful later. Now I'm going to add something to a date. Often that can be quite tricky as dates and times go over boundaries, but there's a function called dateAdd which lets you add in to a date a unit, such as year. Now there are, if I click on this button here, we can look at the help for this function. So dateAdd is this one. And you can see that it's giving you some help. If you want to look at consult the actual help, you'll find a full list of all of the possible units you're allowed to do. So you can have, hours, minutes, months, and so on. So anyway, what I'm doing here is I'm adding 21 years to the date in 1994, and the result of that is the 3rd of February 2015. Just so happens to be my daughter's 21st birthday. So that is her birthday in the year 2015, over a year away from now. This next attribute is the future date that I've just calculated. I'm trying to work out what day of the week that is. There are various format strings you can use. So in addition to YYMM and DD you saw here, there's EEEE, which gives you the day of the week. And if you're interested, I'll show you shortly the full list. But if I use date_custom with the future date with this formatting string, I get returned Tuesday. So I can safely tell my daughter that her birthday will be a Tuesday when she's 21. As promised, I'll just show you briefly the other allowable strings you can use. If you visit this URL, this you'll get this table, which I just copied into the comment section of the process. So I'm using E, which is this one here, and 4E turns it into the long form of the day. But you'll see I'm using Y, M, and you can use the week in year, week in month, all sorts of things. I'll leave it as an exercise for the reader. There we go. Anyway, so if I go back to the results view and just put everything back to where it was, let's now look at the final two attributes here: date time, my date hour, date time, my date 5 minute. So this is a method of truncating the Unix time to a boundary, which could be the number of minutes, 5 minute boundary, or an hour boundary. In this case I'm doing hour and 5 minute, and you might do that if you want to join examples or test results rather from different sources where the times aren't completely synchronized, but you know you have measurements within a time window that you want to combine together into a larger result. And the only way to do that is perhaps to join by date and time to a nearest boundary, say the nearest minute or the nearest hour, depending on what you're doing. So the way you do it, one way to do it, is to use this Unix date and time, this Unix seconds number that you've calculated. I've had to add on this hour here to cater for that strange GMT problem. But if I do that, I can essentially turn my date into the first hour before that date. So if you remember, my date was 17:44 in the afternoon. The hour before that is at 5 o'clock. So this calculation here is doing that, and it's using floor and various date parse functions, and by dividing and multiplying by things like this, you end up with a rounded number. You can do the same thing for 5 minute boundaries. So this is showing the first 5 minute boundary that preceded my time here. So in other words, I could, if I had multiple measurements, put them all into this time window here and then join them together, and by that method I'd get a joined up example set for whatever reason I might have. Needless to say, there are other ways of calculating these sorts of things. There are various date to numerical operators, which we will cover in another video, but this is just one way that you can use to do this. Okay, so I'll leave the video. I'll leave these things up here and just for a few seconds so you get the overview.